Superman, one of the most iconic pieces of media of the 20th century. Superman has been the childhood of many generations, and if you ask anyone today whether they have heard of Superman, they are almost certain to say yes. But due to the fact that most people watched Superman growing up, they were unlikely to ever stop and wonder about the physics of the man in blue pajamas. And for that reason, we wanted to go into a deep dive into Superman's most incredible feats, such as stopping a plane or reversing time. The first scene we will be taking a look at happens in the 2006 movie Superman Returns, where Superman has been absent from Earth for 5 years. The scene involves Superman returning, and as he is returning, he notices a plane in free fall. Since Superman is a hero, he goes down to save the plane. The plane he is saving is a Boeing 777, which will be important later on. Superman flies down and intercepts the plane by the nose and proceeds to push it while it is falling down, eventually managing to stop the plane before it hits the baseball field. After that, he lays the plane down onto the baseball field and leaves. But is this actually physically possible? In our calculations, we need to know the speed or the velocity of Superman so we can find the acceleration to calculate the force. Now, we will start by using the barometric equation for pressure to find the height at which the plane is flying at. Now, in the movie, there is a scene where they're showing the pressure, or not the pressure, but they show a command table where there's a sort of here, and then you have maybe like a couple things here, and then you have something here, something here, and then they have the pressure here, and it's measured in hectopascals. So with that knowledge, we can just input that into this, the pressure, but first we're going to solve for H. We just input this here, and P0 is the atmospheric pressure at sea level, where H is the height of the atmosphere, and from this we get that H is 12.8 kilometers. Now, this is something we're going to save and use for later, but then we'll start with this equation, mdv dt equals mg minus kv squared. Now, that here, and then we get the velocity, which comes out to be around 290 meters per second. Now, afterwards, we can analyze in the video that when Superman intercepts the plane, there are approximately 30 seconds between when he starts intercepting the plane and when the plane reaches a full stop. Now, we're going to assume that the acceleration is constant just because it makes the math much easier. And then we get that since t is 30 seconds and the velocity is 290 meters per second, we get that the acceleration is roughly 9.67 meters per second squared.
Okay, so as Eysteinn said, we now have the acceleration while Superman is catching the plane, which is 9.67 meters per second. And now we can just put that into this formula where force equals the mass times acceleration to get the total force it requires per second to catch the plane. And it's 2.9 meganewtons. And to get the tensile strength of the airplane, we put this formula where sigma UTS, which is the strength factor of the aluminum, is equal to 2p RT, where T is the thickness and R is the resistance of the material. And that is equal to 450 megapascals, or about 650 tons, which would be enough to hold off the plane. But he is catching the downside of the plane, so what we require is the buckling force. And the buckling force is this, which is 30 kilopascals, or 4 tons, which is clearly not enough to hold up the plane.
and I couldn't even save him.
The next scene we will be taking a look at is from the 1978 movie Superman. In this scene, Lois Lane has died, so Superman decides to fly around the Earth to reverse time. This is one of the most famous scenes in cinema history and possibly the first thing that comes to mind when thinking of Superman's heroics. But is such a feat physically possible? So, is this possible? I think the obvious answer is no. How would Superman be able to turn back time just by spinning the Earth in the other direction? That's pretty ridiculous. We all know that. But if we say it were possible and Superman were spinning the Earth around, what would happen? Well, first of all, there would be ginormous tsunamis everywhere. The winds would be crazy and possibly all of humanity would die, at least most of it. But then we have another question. Can Superman even turn the Earth around? Just by flying around it, how would that work? Well, we can try to use the conservation of angular momentum to explain that phenomenon. How fast would Superman need to go for his angular momentum to cancel out the Earth and spin it in the other direction? Well, the first step to calculating that is to figure out how much angular momentum is in the system to begin. And the only angular momentum really is the spinning of the Earth. And the first step to calculate the angular momentum of the Earth is to find out what its moment of inertia is, which is a physics way of saying how hard is it to spin this object. And since the Earth is a sphere, and if we plug in our values for the mass of the Earth and the radius for the Earth, we get that the moment of inertia for the Earth is 8.1699 times 10 to the 37th kilogram meters squared. The second step is to find the angular velocity of the Earth. Per second, we find that it's 7.29 times 10 to the negative fifth radians per second, which is the constant we see here. So finally, how do we figure out the angular momentum of the Earth? And there's a simple formula for that. The angular momentum is equal to the angular velocity multiplied by the moment of inertia. And using these two constants and this formula, we get this value for the angular momentum of the Earth. So, since we know how much it spun and in how much time it happened, we can easily calculate the new angular velocity. In the final angular velocity is 0.0105 radians every second. And that's where we get this value here from. And now, since we know how fast it's spinning, we know its final angular velocity, and we know its moment of inertia, it's the same as we started with, we can use this formula again, times L is equal to I times omega. Find now how much angular momentum would Superman have to add to this system to make this change from this starting angular momentum to this final. We simply have to add together the starting angular momentum to the final angular momentum. And then we get the total angular momentum, which is simply 8.610 times 10 to the 35th kilogram meters squared every second. So now we know how much angular momentum Superman needs to add to the system. But how fast does he need to go to add this amount of angular momentum? Well, to know that, we need to know his moment of inertia. Plugging into this formula, we get that the angular momentum, the moment of inertia, for Superman is this value. So knowing this value, his moment of inertia, and knowing the angular momentum he has, we can use this equation right here again for the angular momenta and the moment of inertia to find what his angular velocity has to be. We find that his angular velocity is 8.122 times 10 to the 19th radians per second, which is a lot compared when you think about the size of the circle he's going in. In fact, his speed is 8.28 times 10 to the 26 meters per second. That's an enormous number. Actually, it's 2.76 times 10 to the 18th, that's one with 18 zeros behind it, times the speed of light. It's almost 3 quintillion times the speed of light. And that's just not possible, as we'll show you in a bit.
The second possibility is it isn't spinning the Earth at all, but traveling backwards through time by going faster than the speed of light. But there's already a problem in this statement, because according to the laws of physics, it's impossible to go faster than the speed of light. This can be shown in many ways, one of which is using the equation E equals gamma mc squared, where gamma is equal to 1 over the square root of 1 minus v squared over c squared. Gamma approaches 1 over 0, meaning that gamma grows infinitely large once v approaches c. This means to get the speed of light, you would need an infinite amount of energy to reach that speed, which doesn't exist. Another way to see it is to imagine if you could get to the speed of light, then all of time would slow down to a halt, and all distances and lengths in the world would contract into one single point. This would violate Einstein's principle of relativity, as you would definitely be able to tell that those effects have happened. If someone were to try to argue that with the Lorentz transformations in Einstein's theory of relativity, as you approach the speed of light, the slower time around you moves. So if you go past c, time should go backwards. But if you plug in the numbers, you see that time perceived is equal to the base time times gamma. But if v is larger than c, we get time perceived is equal to the base time times 1 over the square root of a negative number. This would be an imaginary value, but since you can't measure time with imaginary numbers, it therefore makes no sense to say it's possible to measure time dilation with the Lorentz transformations when exceeding the speed of light.
So in conclusion, while Superman is the symbol of heroism and has inspired generations to come, however, whether he is catching a plane or reversing time, most of his feats are physically impossible.